Hey everyone, today I'm going to talk about the binary search algorithm. So, binary search is a widely used algorithm in computer science for searching an element within a sorted array. The key idea behind this binary search is the divide and conquer technique, in which we repeatedly divide the search interval in half until the desired element is found or the search interval is empty. Basically, if we have a function which can divide the array into two parts. First is true and false, or false or true. Then we can use the binary search algorithm. The input to the binary search is a sorted array or a array which can be divided into true and false after applying a function on its element. So then we can use this binary search algorithm. And then in the initialization step, we will pass the first index and the last index of the array or the interval which follow this true and false sequence. And the this comparison is a function which can divide the array into two part. And then, as you know, the binary search is the based on the divide and conquer technique. We divide the array into two halves until it our target is reached or this interval became empty, or and then we going to repeat this divide and conquer technique to find the answer. So let's try one question. Given target and a sorted array a, find index I such that AI should be equal to target, or report that no such index exists. By sorted array, I means the array sorted in a increasing order. So one brute force approach is to iterate over the array, compare every AI with target. If we get the target, return that index. But this solution required the time complexity of O of n. But if we use the binary search, we can find the answer in the worst time complexity of log n. Let's take an example. Let's take a sorted array of size 15. uh, this array is sorted in increasing order. So a first step to initialize our low and high index, and in case, as you know, we are considering this array as a sorted array, so we will take the entire array as our initial interval. So low become 0 and high become 15 minus 1 14. And let's start the iteration. For dividing this function into two parts, we need one function that will divide this uh, array in a form of true and false. So we will take the function if x is greater than or equal to our target. So at the first iteration, first we find the mid of this array. With 0 plus 14 is 7, so mid becomes 7. And then we compare if this 53 is less than or greater than to our target. If this element mid is less than our target, then we will move our low to mid plus 1, or if it is greater than our target, then we will move our high to mid minus 1. As you can see, our mid element is 53, so it is greater than our target, so we will update our high as mid minus 1, and then our low becomes 0, high becomes 6. And then again we going to find the mid element, so 0 plus 6 is 3, so our mid element is 25, which is less than 33, so we will update our low to mid plus 1. So then again low is 4 and 5, so we again going to find the mid is 5, so then we compare this 43 with 33, then as you can all see that 43 is greater than 33, so we will update our high to mid minus 1, and then we're going to find the mid element, and as you can see that our mid element become equal to 33. So then we will return this index and our answer is 33. As you observe that we are able to find this answer in in fourth iteration, which is nothing but log to 16. So we are able to find this answer in a worst time complexity of log to n instead of n. So as you can see that how much our time complexity is improved. So as you can see, the searching is based on the divide and conquer technique, and our idea is to choose a middle element. If k is equal to the mid element, then we are done. Otherwise, we will update our low to low or high based on the output of our function, and we will repeat this until either k is found or no more element is to be searched. For solving this question using binary search algorithm, I defined a function binary search which take two argument a vector of integer array and integer k. Here k is nothing but our target, and we will return the index which satisfy the condition ai equal to k of, or if this condition didn't satisfy it, then we going to return -1. And for initialization step we define the index low, which is nothing but the starting index of the searching interval, and high equal to array dot size -1, which is nothing but the ending interval of the searching interval, and we going to repeat this condition until our searching interval become empty, or we find our this index. we find the mid. You can use a simple technique, low plus h divided by 2 for finding mid, but I use low plus high minus low divided by 2. uh, and but this is not required in for our case, because as you know that the size of the vector can be at max or something 10 raised to power 7 or 10 raised to power 6, but in some cases when we are going to use this, not going to use the array index as a function, but we're going to use a number as a function. It may happen that our low become 10 raised to power 9 something, but and our high become 10 raised to power 9 something, and then it may that our low plus high can exceed our 32-bit integer limit, which may result into some negative value, which is not a good thing, and we will came with the wrong answer, which is not a good thing. But you can say that why can't we use this low and high as a long integer? Because if we use this low and high as a long integer, it may consume more memory, which is not a good thing. So after finding the mid, we're going to compare the array mid with k. If it is array mid is equal to k, we're going to return this mid, and if it is not, then we going to compare if our array mid is less than k, then we going to update our low as mid plus 1, and otherwise if it is greater than k, we going to update our high as mid minus 1, and we going to repeat this condition our until our low is less than or equal to high, and then uh, we at the end we going to return minus 1, because we didn't find this index whose value is equal to k. Yes, and in the next part of this video, I'm going to talk about how we can find this function which can be used to divide the array or the searching interval into two different parts. First is true and then false. So do not forget to practice these concepts, code, compete, and win.